Good morning. Today we're going to be talking about Module 1, Lesson 2. And in Lesson 2, we're going to try to find out how is the size and the shape of lunar craters affected by different factors. So we're going to start off with a quick write, and we're going to write this down in our notebook. And they want to know if you had a small mass or a large mass, how would that affect the size and shape? Or if you had a small diameter or a large diameter, how is that going to affect the size and the shape of a crater? Or you had a meteorite with low speed versus high speed, how would that affect the size of the crater? When we start the lesson, they start to give us some vocabulary so we can be more accurate in our descriptions. Initially, when they started looking at the moon, they thought the dark areas were the sea, so they called them Maria. And they thought the lighter areas were the land, and they called them lunar terra. In the lunar terra, we find a lot of craters. The craters have vocabulary that you can use to describe them. The floor is the bottom. Anything that comes out of it is called ejecta, and it may come out in lines or streams, and if it does, they call a ray. There is a raised rim, where it's up above the outside layer, or it could be raised in the center, and that's called a central uplift. The other word that you could use is you could use the wall to describe the part that goes from the floor up to the raised rim. So when you're describing your craters, you may want to use some of these words so we know exactly what you're talking about. Now, we found out that asteroids, meteors, and meteorites are what cause the craters on the moon. There's three main classes. There's a C-type, an S-type, and an M-type. The C-type is the least dense. It's made of silicate rocks. The S-type is medium density, and it's a combination of silica rocks and iron and nickel. And then the M-type is the most dense, and that's going to be made mostly of iron and nickel. They travel at about 25 kilometers per second, and an asteroid piece that hits the moon is called a meteoroid. So what they want you to do, and you try it, is you're going to design an experiment that tests the effect of size, mass, and shape have on the formation of a crater. And you're going to have to decide what data is most important to collect to prove your point. So what I did is I went around the house and I collected some different balls, and these were balls that I had around the house in different areas, and I tried to find different sizes. I tried to find different masses, so I had different densities. And the other thing I was going to do is I was going to drop them from different heights, and that would give me the speed. So the three very different variables is diameter, right? Small diameter, large diameter, mass, high mass, low mass, and then I dropped one from 25, and the other ones are, and then dropped it again from 50, so I could test the different speeds. And what I did is I dropped it into flour. Now, if you're going to do this at home, which you probably should get permission because I made a big old mess all over the floor, and I don't want you to get in trouble. So I put flour in a baking pan. It's probably about 2 inches deep. You might want to put something on the floor because when you start dropping the balls into the flour, it tends to go outside of the baking dish. So I have my meter stick, I have my different balls, and I use this to smooth it out so after I made a crater in the flour, I could go back and I could smooth it and start with a smooth surface again. So after I dropped, I ended up with these different craters, and some of them are pretty nice. You can see the ejecta around the outside, you can see the raised rim, you can see the floor, you can see the wall. So it has a lot of the characteristics that we're looking for. But when I'm testing different variables, I have to decide what I'm going to test. I don't want to just drop this from 25 and this from 25 because it doesn't tell me anything about speed. If I want to test speed, I want to test one ball, and I want to drop it from different heights. I could drop it from 10, I could drop it from 25, I could drop it from 50, and that will tell me what speed has to do. So you don't want to change two variables at one time. You only want to change one. So if you're going to do speed, you change height. If you want to change diameter, you probably should get balls that are very, very similar. I might pick a small pool ball and a big pool ball, because they're made the same way and they have approximately the same density. The difference between these two balls is going to be the diameter. So if I want to test diameter, I would take these two balls and compare that dropped from the same height and how the craters are different. I didn't really have much for shape. The only thing I had to do with shape is I could have looked at the holes the wiffle ball has versus the laces that the baseball has, and the grooves that the tennis ball have, and see how those change the shape of the crater. So like we were saying, the variables you're going to test is you're going to either test mass, and that's called the amount of matter in an object. That's the definition for mass. Size is the diameter, and speed is going to be the height that you dropped it from, because the longer it falls, the faster it's going to go, because things constantly accelerate until they hit terminal velocity on Earth. The next part of the lesson, they're going to start talking about what motion is, and they want a good definition of motion, and the definition they come up with is motion is a change of position, and they talk about it as a frame of reference. So I have two different flies. I have one fly that's riding inside the car, and I have one fly that's outside of the car. If this fly is looking inside the car at the steering wheel, and you ask the fly if the car was moving, he would not notice the car was moving because his frame of reference is inside of the car. He seems to be thinking he's sitting still. But the car that's in front of the bug that's in front of the windshield would definitely think the car is moving, because he would be flying there and he would see the car coming at him really, really fast. So depending on which fly you are, you'd have a different frame of reference. Inside the car, no, I'm moving the same as the car is, so it's not moving. And outside of the car, it is definitely moving because I'm going to get crashed on that windshield. They also talk about a definition for force, and a definition for force is a push or a pull. Any push or a pull is a force. So the pull of gravity, that's a force. If I pushed on this rock, that's a force. And any net force, or force that's stronger in one direction, ends up causing motion. Motion is opposed by friction, and friction is another force that resists motion. So if my motion is going this way, my force of friction is going this way, the opposite way. So if we apply these to a meteorite crashing into a planet, you would say that the motion is in this direction. So when these two hit, the meteorite is going to apply a force to the planet here in this direction. There's going to be friction back the opposite way of the motion, because friction is a force that opposes motion, and that's where you get your ejecta. As the ejecta comes up out of the crater, it's going to start to deposit outside, and that's where you get your raised rim and your wall and your floor. So what the results of the experiment were is the larger the mass, the deeper the crater. The larger the size, the wider the crater. And the faster the speed, the deeper and wider a crater is. So if I look at a deep, wide crater, it was either a very large or very fast. If I see a very small crater, it was not as fast, or it did not have a really large mass.